Today's problem is minimum cost to cut a board into squares, difficulty medium. The accuracy is pretty high, 60%. The accuracy as well as, well, let's go down and look at it. Top of it, greedy. Okay, so the combination of those two things is a good indication that your initial intuition on this problem is likely to be correct. The challenge is, given a board of dimensions n by m needs to be cut into n times m squares. Cost of making a cut along a horizontal or vertical edge is provided in two arrays. Let's see. X. Oh, so we get the X array, which is the cost, the cutting costs along the vertical edges, lengthwise. Okay, so in this case, like X 2, 1, 3, 1, 4, that is the cost of the vertical cuts. And then Y, we have the Y array as the cost of the horizontal cuts, 4, 1, 2, those, so here we have 4, 1, 2. Find the minimum total cost required to cut the board into squares optimally. All right, and then they have an example. Now, if you look at the example, the optimal way to cut this into squares is make a vertical cut at a cost of 4 times the number of horizontal segments, and then we have 2 vertical segments. Why we don't have 2 horizontal segments as well, I don't know, but that's the rules of the game. 4 times the number of horizontal segments, which is 1. Next, 4 times the number of vertical segments, which is 2 vertical segments, so that's 8. And we have 3 times 2 vertical segments, and we have 2 times 2 horizontal segments. Where are we? Then we have 1 times 3 horizontal segments, 1 times 3, 1 times 6. Add everything up, we get 42. Well, you can see what's happening here is we're picking the biggest numbers first. So it's a greedy algorithm. Pick the biggest number, because as we go through this, the number of segments is going to increase. So we want to use up the larger costs first when we can multiply them times smaller numbers of segments. We don't want to multiply big numbers times big numbers of segments. Okay, the next one, well, everything is a 1, so it doesn't really matter what order you cut it in. N and M are going to be between 2 and 10 to the third, 1,000, 1,000 by 1,000, X, I, and Y, J. Oh, I see. That's the cost of the cut. Between 1 and 1,000. Expected complexity. So it looks like we have a couple of sorts here. And topic tags, greedy. Okay, yeah. So we get to do sorts. All right. That's here. We'll sort these things. We'll set the number of segments, which is initially 1 for both horizontal and vertical. We want to pick the biggest numbers first. So we're going to go from right to left in the array. We could sort the array in descending order. In Java, that's not so simple with ints. You know, they need to be integer objects in order to put a custom comparator in there. So let's see. So we'll start with the indices at the highest possible point, m minus 2. Why is it m minus 2? Well, let's see. M minus 2. Now in this example, m is 6. That's the dimension, the horizontal dimension of the board. 6. But the size of the array is 5. So the biggest index is 4. So to get to the biggest index, it's m minus 2. Same thing here, n minus 2. Total, initialize it to 0. All right. We're going to iterate through these arrays. As long as both arrays still have something in them, we're going to stay in this while loop. And we're going to pick the biggest number. So is the x, what is x? X is the vertical cut. If the costliest vertical cut is greater than the costliest horizontal cut, then we're going to make the vertical cut. What that is going to cost us is cost of the vertical cut times the number of horizontal segments, increment the number of vertical segments, and decrement the index. On the other hand, if we don't have a vertical cut that is greater than the horizontal cut, then we'll do the horizontal cut. Cost of the cut times number of segments, increase number of horizontal segments, decrement the index. What if it's a tie? Doesn't matter. For example, we have a vertical cut here for a cost of 4. We have a horizontal cut here for a cost of 4. Which one do we pick first? Well, it doesn't matter. Whichever one we pick first is going to be 4 times 1. Whichever one we pick second is going to be 4 times 2. All right, so when we run out of cuts in one of the directions, either the horizontal or vertical dimension, then we're down here. So let's see, if I equals 0, that means we still have if I is less than 0, that means we still have horizontal cuts. So we just go ahead and make the rest of the horizontal cuts. On the other hand, if we still have vertical cuts, we go ahead and make the rest of the vertical cuts. And then return the total. All right, let's run this and see what happens. All right. Let's see. Yeah. So go ahead and like the video and subscribe to the channel. It's free. I'll send you problems of the day. They'll show up right in your inbox, and we'll see you next time.